You know, at the beginning of every harvest, you and I fine-tune our machines to get them the best they can possibly be. The technology we have in the combine from the seat, we learn a lot about the box or the combine itself. But up underneath the head, that's a loss that you and I have to get out and do a little bit of physical work to understand what that is. So as we look here, every square foot, 2 kernels in a square foot equals a bushel. Pretty common to find 2 to 3 bushel loss underneath these corn heads. So let's just take a look. You're gonna have to get out of the seat. You're gonna have to get out. In our case, I just stop the machine, stop the head, and I back up. So that gives us about 20 feet in here that we can work with. I take 3 rows worth, which is 6 feet, 6 inches on the first row, of course the middle row and everything in between, and then 6 inches on the third row. So that's 6 by 10 is 60 square feet, and then I go in and measure it off. So in this case, we'll just measure off 10 feet, and we'll put a second flag, and then we just go to work and we count. And so let me just give this flag. I just go ahead and work right through the residue itself and take a look to see what we got. We realize the center of that combine where the feeder house is going to be the problem spot. And I just mark every kernel. And every kernel I see, I just start to put flags. In this case, we have this combine split. Rows 1 through 4 are yield saver. Where I'm at here on this side of the machine, here is we're on the OEM side. And the deck plates are shut down really tight. But at the same time, this corn's testing 17.9, and so it's not too hard to come out and you start to find these kernels. And so we just go through and we mark all 3 rows, and we take a look and do a little simple math and make the adjustments that we can. The problem has been for years, the adjustments that we make, if the deck plates are all the way down on 1 or 0, and we're still getting this kind of loss where I got 5 kernels here in a matter of a very short space, the only option then is to start to look at new technology, such as a 360 yield saver. Once you and I establish the actual loss that we have underneath this 20-foot head, it's pretty easy to go behind the machine then, and now we're looking at sieve loss and tailings loss and what's coming out of the top of the rotor. The difference in those two is what the combine has. So once we establish head loss, we go behind the machine and we get the total, subtract the 2, then we go to work on the box itself, saying, do we need more airspeed? Do we need to open our sieves just a bit? Or maybe we just need to change the rotor speed itself.